Our country is facing a bit of a dilemma with its aging infrastructure. Everybody knows that the infrastructure has gotten a bit older than it should be, but we can't manifest all of the money and the manpower that we need to repair everything to what it should be repaired to.
Corrosion is costing the Department of Defense $20 billion with a B per year. That's the cost, and that is a big cost.
There's a lot of science that goes into keeping the environmental conditions off the surfaces of our infrastructure. Because it's when the moisture or the salt or the UV start hitting the materials that create our infrastructure that cause it to start eventually breaking down. Our locks and dams are part of USA's infrastructure, and these are largely made of steel structures that some are in mild conditions, but some are in very harsh conditions. And without the coatings on them, the maintenance on them would be at a rate of at least yearly. And when we start shutting down our locks and dams to do maintenance, we're shutting down a global system economy. And most people don't realize that you can shut a dam down, but you're stopping the shipment of important goods from one side of the country to another. And so being able to put on a coating and help protect that structure 40, 50, 60 years from maintenance keeps that cost down and makes sure that our economy is flowing.
If we can do a dent of like $3 billion per year, inventing like new coats, different ways, different material, different setups that can avoid the rapid deterioration or prolong the age of the assets and the infrastructure that we have, we did take a bite out of that problem.
When I came to the ERDC, I began looking at different ways to assess infrastructure. The low modes of bridges, which is the way that they flex, happens to be in the infrasound passband. A really big bridge bends in really big ways and creates low frequencies. So I looked at the possibility of using these structural acoustical emanations as fingerprints for those structures to determine how good they're feeling. And if you can do this from non-line of sight, tens to 20s of kilometers away, you can monitor wide areas with a very small manpower footprint with very affordable equipment.
An example of work that we've done in the past is like the reinforcing of the Pentagon. So before 9/11 actually occurred, the Corps of Engineers here at ERDC was helping with the redesigning of how we reinforce the infrastructure itself, everything from the windows to the walls to the supporting structure within inside the Pentagon. And by happenstance, the area that had just been refurbished in the Pentagon was the area that was hit by the plane on 9/11. So numerous lives were saved because of that sort of facilitation of re-enhancing or enhancing the Pentagon facilities.
Our simulators are used for channel design. It allows us to move things around really quickly and test a lot of different scenarios and see what's feasible. Whether you make a modification to deepen, to widen, to increase the dimensions of a turning basin, engineering regulations says you must simulate those changes. We can test so many different scenarios. We don't destroy any property, we don't break anything, we don't hurt anybody. And by doing that, we reduce the risk of us doing those very things in the real world. We reduce the risk of running a ship into the Riverwalk in New Orleans, or spilling oil in Prince William Sound. And that's how we make this a safer place for everybody.
Well, we are in Hangar 2. This is one of our accelerated pavement testing facilities here at ERDC. And the piece of equipment that's behind me is our heavy vehicle simulator. And what's special about this facility and this equipment is that it allows us to put 20+ years of traffic, whether it be aircraft, vehicle, rail traffic, on a test section within a few weeks. We develop materials, tools, techniques that can be implemented in the civilian sector. Some of the materials that we've identified to repair airfields can also be used for dams. It could be used for roads. It could be used for civilian airports and airfields.
The Engineer Research and Development Center is developing many materials for the rehabilitation and repair of infrastructure, making it easier, quicker, and cheaper to provide improvements to our nation's infrastructure.
We solve impossible problems, and we let our researchers really explore their imagination to find out how they fit together and how we answer the Army's needs now and tomorrow.